Okay, in this little example, this is a simple circuit. It's one loop, no junctions. And I'm going to look at the questions of what is the total resistance of the circuit, what is the current and its direction, and how much power the circuit uses. I'm going to use some Kirchoff's laws, and then I'm going to use some of the other stuff that we've done in the past. To begin with, I'm going to kind of set this problem up by just assuming a direction for the current. So I've picked clockwise. No reason, again, it's just an assumed direction of the current. Now the thing about this current is all the elements are in series, and they're in series because it's one resistor after another and no junctions in between it. Our rule doesn't say anything about there not being batteries in between the resistors, so they're not going to affect the resistance at all. So I'm just ignoring the batteries. Another cool thing about the series, everything being in series, everything's also going to have the same current. Because there are no junctions, the current doesn't split. So once I find it for one part, I've actually found it for all the parts. So if I look at it in series and I add everything up, it's pretty easy. I get a total resistance of 7 ohms because I'll have 1 ohm plus 1 ohm plus 2 ohms plus 3 ohms, total resistance 7 ohms. Didn't need to do anything with Kirchoff, just one of my basic rules. Next, I need to look at the current and its direction. To solve this, I need to organize my thoughts. So I'm going to pick this analysis direction. This is how I'm going to organize my thoughts when I start subtracting and adding the current drops. And I've just picked counterclockwise as an arbitrary direction. I'm going to start here at the bottom right between the 10 volt battery and the 3 ohm resistor, and I'm going to go in a counterclockwise direction. Now as I do this, because of the way I chose earlier for my direction for the current, I'm going to be going against my current, which means if I'm going against the current across a resistor, I subtract I times R, because V equals IR, or the change in voltage equals IR. So every time I go across one of the resistors, I'm changing the voltage in my loop theorem. Because I'm going against the direction of the current, I add it. So when I set this up, I start at my point and I go upwards. I'm going against the assumed direction of current, so I add I times 3 ohms. For my battery, I ignore the current, and I just look at the battery as going from negative to positive in my direction of analysis. So I add 7 volts when I go from negative to positive. Then my 2 ohm resistor and my 1 ohm resistor at the top, for both of them, I'm going against the current. So I times 2 ohms plus I times 1 ohm. Across my 9 volt battery, I'm going from negative to positive, ignoring the current. From negative to positive, you add the voltage. And along the bottom part, I'm going against the direction, the assumed direction of the current, so I add I times R for the 1 ohm resistor, so I times 1 ohm. And then finally for the battery at the bottom, I'm going from positive to negative, so I subtract the voltage, get minus 10 volts. And all that's equal to 0. Now again, the voltage used up by the resistors comes from Ohm's law. That's the V equals IR stuff. I can simplify this a little bit, so I get 10 minus I minus 9 minus I minus 2I minus 7 minus 3I equals 0. And then I can solve this for I. And when I solve it for I get a current of 6/7 of an amp. So everything in my circuit has a current of 6/7 of an amp because there's no junctions and everything's in series with everything else. So that's the answer to the second question. Third question, how much power does this circuit use? Well, I have a couple choices in terms of my power formulas, but since I know the resistance and the current, I'm going to use the power formula that has current and resistance in it. So P is equal to I squared times R. So if I do that, I look at my total current, since it's the same for everything, 6/7 of an amp, squared times the total resistance for the circuit, which is 7 ohms. So it just becomes 36 over 7 watts. And that's the total power for the circuit.